Hello all, welcome to my YouTube channel. In today's video, we are going to discuss about Microsoft Azure Load Balancer services. So basically load balancing refer to eventually distributing load like incoming network traffic across a group of backend resources or servers. So let's start. So basically we are going to cover all these topics in today's video. First we have introduction of Azure Load Balancer. Next we will discuss Azure Load Balancer types. Next we have components of Azure Load Balancer. Next we have workflow, features of Azure Load Balancer. Then we have Azure Load Balancer SKUs. SKUs called a stock keeping unit. We will discuss later in this video. Next we have load balancer coverage or limitations. Finally we will create a load balancer and we will see how to distribute the traffic. What is load balancer? So Azure Load Balancer is a platform as a service to allow load balancing of traffic to virtual machines or virtual machine scale sets running in Azure. As you can see in this diagram, this is our internet. Basically end user is sitting behind this. So end user is raising a request to access the application which is deployed in this virtual machines instances on this particular port number. So what end user will do, they will raise a request or try to access the particular application on this port 80. But what the load balancer is doing, as soon as the load balancer receives the request, it will distribute the particular request to on a specific virtual machine based on the load balancing rules or health probes which we will define during the creation of Azure Load Balancer. So Azure Load Balancer is a layer 4 load balancer which worked on TCP and UDP protocol. And Azure Load Balancer provide high availability of your application because so basically what it does, with the help of health probe, suppose user raise a request to access this particular application on this VM, and with the help of health probes the load balancer will monitor these virtual machines. If load balancer found out this virtual machine is not accessible, then it's automatically redirect that request to this particular VM. So that's how basically load balancer redirect or distribute the traffic to the set of virtual machines instance. Next we have types of Azure Load Balancer. So basically there are two types of load balancer, external or public load balancer, or we have internal or private load balancer. So a public load balancer can be used to load balance internet traffic to virtual machines. So in this example you can see this is a symbol of virtual network. So we have one virtual network and the request is coming on this a particular load balancer, and we have a public IP address on this particular load balancer, and this public IP address, we know that public IP address basically exposed to the internet. So on this particular public IP addresses we are getting the request, and with the help of Azure Load Balancer we are distributing this particular request to the set of virtual machines based on the rules which we will define. So in this model, in this mode basically load balancer is assigned a public IP address to ensure that load balancer can accept requests coming in from the internet. The load balancer will get called from the internet by the client application or software like Google Chrome, Microsoft Edge, such kind of softwares or applications basically we use to access the web application. And then based on the configured rule, it will distribute the incoming traffic over virtual machines. It could be applications or containers. So based on rules basically it will distribute the traffic to the set of VMs. So that's how basically a public load balancer work. Next we have internal or private load balancer. So internal or private load balancer is used to balance traffic from within the virtual network. So basically when we used internal load balancer, that is not exposed to the internet. So if you see in this particular diagram, we have two load balancer, external load balancer and internal load balancer. But if you see in external load balancer, we have a public IP addresses which is exposed to internet. So if we see in this particular diagram, end user request is raising on this particular public IP address. From this public IP address, the request is going to this front end. Now, if you see in front end, we have an internal load balancer here where we have private IP addresses. So private IP addresses can easily connect to each other's within the virtual network. So with the help of internal load balancer, basically it's distributing the traffic to application server on database tier. Based on the request, it will distribute the traffic. So that's how basically internal load balancer work. So the internal load balancer is essentially the same as external, but it uses a private IP address, and thus it can be called only from the application within the virtual network to which it is attached. So if end user directly call to this particular internal load balancer, they cannot call because it's not exposed to internet. So that's why this diagram shows we have a request to the external load balancer, and from external load balancer, its request is forwarding to the internal load balancer, and from internal load balancer, we are forwarding request to the particular application server or database servers. Next, we have components of Azure load balancer. Front end component basically consists three components: public or internal IPs, transport protocol, TCP or UDP, and port. So basically what happened, it is the IP front end, basically it is the IP address to which the incoming traffic will initially come to, and Azure load balancer can have one or more front end IP addresses. Based on the requirement, basically we create the front end IP addresses. So these are something called as virtual IP addresses. So whatever the first request we get from the end user, it comes to the front end IP addresses. Next, we have a backend pool. So these are the pools of virtual machine to which the traffic will eventually go. So these backend pool are nothing but, if you see in the previous slides, these are the VMs. Basically, this is called a backend pool. So basically, we create a pool and we associated these VMs on a particular pool. So that's called a virtual machine backend pool. Azure load balancer backend pool. So VM, which would be load balanced, VM NIC or network interface card would be attached with the load balancer. So it will, from front end, basically it will forward the request to the backend pool, and we will get a response from the applications. Next, we have a health probe. So health probe basically to monitor app status, we generally use health probe. So health probe, there are some required parameters like port, path, interval. So those all the parameters basically we need to pass when we create a health probe. We will see in a demo. So health probe originate from the IP address. This is the particular IP address, and this IP address should not be blocked in your network, because from this particular IP addresses, health probe generates. So we need to, when we configure load balancer, we need to keep in mind this particular IP addresses should be allowed in your network, in your firewall. Next, we have load balancer rule. So load balancer rule is just simply a mapping between the front end IP configuration and the backend address pool. So basically, whatever we are mapping between front end and backend with the help of load balancing rule. We map the front end and back end, so we can easily redirect the traffic or distribute the traffic amongst the VM or a group of VM. So these are the basically rules: front end IP protocol, front end port, back end pool, back end port, health probe, session persistence. So those all the things we need to define when we create a load balancer rules. Now it's very important part, how basically Azure load balancer workflow work. So in this diagram, as we can see, we have an internet, basically end user, we can say here sitting on this internet. They are raising the request to the public IP address or external load balancer basically, and from here it's redirected to the backend VM pool with the help of private BIPs. And here we have an internal load balancer, and then we have a backend VM pool. So traffic is flowing in this way. So we will see. So Azure load balancer receive incoming traffic in front end virtual IPs. So in the front end will be somewhere here in external load balancer. And for external load balancer, the front end VIP is a public IP address basically. So internal load balancer, the front end VIP is a private IP addresses. So we need to understand here two terms. For external load balancer, the front end VIP or virtual IP is a public IP, and for internal load balancer, The front end IP will be virtual IP is a private IP addresses, because in internal load balancer we were creating the private IP addresses. And the incoming traffic is received through a certain port which is configured. By default, port 80 is enabled. Like when we create a load balancing rule, so by default it will create a port 80. Upon receiving the traffic, the load balancer check the LV rules, and based on the rules it forward the incoming traffic to the backend pool. So see, if you see here, we have a backend pool. So whatever the rules we have configured in this particular load balancer, accordingly it will forward the particular load or traffic to this BM pools. The destination we have, when we create a pool, when we configure this thing, load balancing rule, we need to configure front end port and back end port. So though both ports, suppose for example we will see we are getting the traffic on port 80 on the front end IP addresses, but in backend we can have same port number 80 also, which is like for suppose one of the web application is running on a port 80, so in a backend BM pool, and in front end BM pool we also have the same port we have enabled, port 80, we will get the request. So it could, so those backend port and front end port could be a same also, or it could be a different also. So it doesn't matter like how are we going to keep a same port or different port, but ideally we should keep a separate port for front end and back end. To ensure all the BMs and application are up and running in the backend pool, Azure Load Balancer monitor the health probe after a specific interval. So when we create a health probe, we specify a particular time period. So in which every 5 minutes, 2 minutes, 4 minutes, 10 minutes, it will basically continuously monitor the backend pool. So in backend pool, what do we have? In backend pool, we have a virtual machine or virtual machine scale sets. So basically it will check the status of the VM backend pool. Are they working, or are the status is okay? So that's how basically the health probe basically monitor all the status. Once we see health probes get a update like, yeah, this BM is up and running fine, then it will distribute the traffic on this particular BM or BM pool. So that's how basically Azure Load Balancer workflow work. Next we have a features of Azure Load Balancer. So first we have load balancing. So Azure Load Balancer, you use a 5-tuple hash composed of source IP, source port, destination IP, and protocols. So we can configure a load balancing rule within the load balancer in such a way based on the source port and source IP addresses from where the traffic is originating. So this is called a load balancing. Next we have port forwarding. So load balancer also has port forwarding capability. If we have a pool of web server and we don't want to access associate public IP addresses to each of the web server in that particular pool. So and if we are going to carry any kind of suppose maintenance activities, so you need to do RDP into those web servers having a public IP address on that particular web server. So basically that's how we configure based on requirement. Generally we do a port forwarding. Next we have application agnostic and transparent. So load balancer does not directly interact with the TCP and UDP or the application layer. We can route the traffic based on the URL or multi-site hosting. Then we can go for an application gateway. Like it's application gateways, and again it's a type of load balancer we will discuss in coming videos. Next we have automatic reconfiguration. So basically this is very good features. So load balancer can reconfigure itself when we scale up or scale down instances. So if we are adding more virtual machines into the backend pool, automatically load balancer will reconfigure those BMs. Next we have health probe, which we already discussed. Then we have outbound connection. So basically all the outbound flow from a private IP address inside our virtual network to a public IP address on the internet can be translated to a front-end IP of the load balancer. That is called outbound connections. Next we have standard load balancer. This is also a SKU, stock keeping unit of Azure Load Balancer. We will see in coming slides. Now we will see Azure Load Balancer SKUs. So represent a purchasable stock keeping unit under a product. What it does mean basically, so based on SKUs, Microsoft charge you. So if you are going to use a basic SKU, then it's a free, but there are some limitations which you cannot use it. So Microsoft always recommended use a standard SKUs, but it charge also. So Azure Load Balancer has 3 SKUs: basic, standard and gateway. Each SKU is created towards a specific scenario and has a difference in scale, feature and pricing. So basically with the help of SKUs, it's a basically pricing we will decide if we are going for a basic, standard or gateway. So accordingly we have to pay to Microsoft. But Microsoft recommend use a standard load balancer. So SKU is nothing but it's a pricing tier of load balancer. Based on SKU, Microsoft charge. You can create a gateway SKU if you are creating internal load balancer. So this is very important thing. If you are going to create a external load balancer, in that case you can only create a you can only use a basic or standard SKU. You cannot create a gateway SKU with the external load balancer. As gateway SKU only supported in the internal load balancer only. These are the features of basic or standard SKUs. If you see SLA, service level agreement, in basic we are choosing basic SKU, we don't have any SLA. So that's why Microsoft recommend to use standard SKUs. So in the standard we get the SLA of 99.99%. Target, if we will see what kind of resources we can add. In basic SKUs we can add availability sets, single instance or scale sets, and with the help of with a standard SKU we can all the resources in a virtual network, like whatever resources we are going to create, we can use those resources as part of standard SKUs. IPv4 and IPv6 public support, yes, these both basic and standard both supports. Then we have multiple front-end IP addresses. So we can have, like generally we create a one front-end IP address, but we can also create a multiple front-end IP addresses. So it's support in both. So basically these are the features. When we are going to create a load balancer, we need to compare both the things, like what based on the requirements generally we use the SKUs, like are we going with basic or standard. So these are the basically features which we need to see before creating a load balancer. Now we will see load balancer coverage or limitations. So there are some limitations with basic and load balance, basic and standard SKUs. So we will see. So you cannot attach a Azure load balancer to a Azure VM in different region. So region like North Europe, Central India, West US. So if you have in different, if your virtual machines are in different region, you cannot attach a Azure load balancer. All the VM must be in the same Azure region. This is true for both basic and standard load balancer. For multi-region coverage, Microsoft has another offering calling Azure Traffic Manager. Again, this is a very vast topic we will see in coming video. So basic load balancer can cover VM from a single availability set, single scale sets and single availability zone. In other words, basic load balancer can work only within a single Azure data center, like in single regions, single data center. Standard load balancer can include VMs from multiple availability set or multiple scale sets. Standard load balancer can also include VM from multiple availability zone. It supports cross zone load balancing, which is a Microsoft recommended an approach to sustain zone failure. So basically when we create these load balancers, there are zone called zone 1, zone 2 and zone 3, and suppose if zone 1 is getting compromised, then all the data will be moved to zone 2. So we can get this feature if we are using a standard load balancer. And starting from March 2019, Azure Global VNet Peering supports standard load balancer. Earlier it is not support VNet peering. If you are not aware about VNet peering, I have already discussed in my previous video in the virtual network this topic, so you can go and watch there. This means you can reach the endpoint of internal standard load balancer from another region if these two regions are connected to the global VNet peering. So cross region also support if we are using the VNet peering. So these are the basically some limitations of Azure Load Balancer. Now we will see the demo how to create a Azure Load Balancer, and we will try to distribute the traffics. So I am on my Azure portal. Here what I have done, I have created the two virtual machines, VM1 and VM2. In both of the VM, I have installed the IaaS server. So if I'll go to this particular VM, and if I'll take the public IP address of this VM, if I'll browse it, so you can see IaaS homepage is coming. So what I have done, I have created a sample HTML page here. If I'll do default.html, so you can see here we are getting this is VM1, and then similarly if I'll go to VM2, so this is the public IP address of VM2. If I'll copy it, /default.html. So this is coming VM2. So this is the default HTML page I have created here. So for this particular IP address, we have this VM1 and VM2. So what I will do now, I will remove this public IP addresses from both of the VM, because we are going to access these two applications from the load balancer. So first thing I will do, deassociate this particular public IP address from this VM. So what I will do, I will go to networking. I will go to network interface. Then I'll go to IP configuration. Then I'll edit this. So I will deassociate public IP address from VM2, and for private IP address, I'll keep it as a static. I'll just save it. Same thing we will do for VM1 also, because we don't require public IP addresses on these two VMs. These two VMs should be accessible from the load balancer. So for load balancer, what we have to do, we have to create a one more public IP addresses for load balancer when we create. So from this is VM1 public IP addresses disassociated is completed. Same thing we will do for VM1 also. If I'll go to networking, network interface, IP configuration, I will edit this and deassociate and keep it as a static. Let's save it. We'll wait for once it's completed. Then what we will do next, we will create a public IP addresses for load balancer. So this is completed. Now I'll go to home page and create a resource, and I'll search for public IP address. So I already have these two IP addresses for VM1 and VM2, but we have deassociated from the virtual machines. If I'll go to virtual machines again, VM1, we cannot see public IP addresses. If I'll refresh this page, it will not work, because we don't have any public IP addresses associated with this particular virtual machine. So now we will create a public IP address for load balancer. So I'll keep SKU, because we are going to create a standard load balancer. We are going to choose SKU standard in a load balancer. So when we create a public IP addresses, we have to choose SKU as a standard. Tier I'm going with regional one. Name I'll put LV public IP. Resource group, I'll choose my resource group LB. Location is Central India, and I'll keep availability zone as a zone redundant, and I'll just create it. So it will take few seconds to create a public IP addresses. So here we can see we have created one public IP addresses called load balancer public IP. Now what we need to do, we need to create a load balancer. So we'll search for, okay, I got it here itself. If you can't, you have to just directly search your load balancer. So I'll create new. Here resource group, I'll choose my resource group LB. Name I'll put BM load balancer LB. Location Central India, and SKUs as we discussed, We have 3 SKUs, so I'm going to create for standard because Microsoft is also recommended to use standard SKU. Now we have type here, so I'm going with public load balancer. Tier I am using regional. This public load balancer also support global region. If I, for example, if I choose internal load balancer, here we cannot use regional. So I'm going with public and global one. In internal we cannot create a global. So I'm going with public as a type and I'm choosing tier as a regional. Next, front-end IP configuration. So I don't have any front-end IP now, so I'll create one. So I'll keep front-end IP. Public IP addresses, we have created a LV public IP address which we will choose it. Gateway load balancer, we don't is none. So I'll just click add here. Now we will go to backend pool. So backend pool and inbound rules, these we will create once we create a load balancer. So I'm not going to configure these things. I'm just going default review and create. So we'll wait for the validation. Okay, validation is passed. Now we will simply create a load balancer. So now deployment is completed. We'll go to resources. And we have already created a front-end IP configuration. So we have already front-end IP. Now what we have to do, we have to add a backend pool. So I'll go here, add backend pool name. I'll keep pool A. Virtual network, I'll choose my virtual network LB. Now we will click here, add. So now we can add both the VM as a backend pool. I'll select both the VMs and will add it as a backend pool. And we will save it. So now we have added a backend pool and you can see resource status is running. Now next, what we need to configure, we need to create a health probes. So I'll just simply click on add. I'll put a name, health probe. I'll choose a protocol. Now here we can see we have TCP, HTTP and HTTPS. If we are configuring a basic SKU, then we don't have option for HTTPS. So my application is running on HTTP port on IS servers. So I'll choose HTTP port here. And as you can see here, we have defined the path here, default.html file. This file basically we are calling. So we'll put this file as a path here. And interval, this is basically interval in every 5 minutes, 5 seconds basically this health probes go to this particular backend pool where we have added the virtual machines and it will check the status, like those are working fine, is there any issues. So those things basically this in this particular time duration it will check and we'll simply click on add. So now health probe deployment is completed. Now what we need to do, we need to create a load balancing rules, because based on load balancing rule, Azure load balancer distribute the traffics. So I'll add the load balancing rule here. So I'll put a name LB rule. I'll choose my front-end IP address which we have created. I have to choose my backend pool. We have a pool A. Port number, I have a port number 80 on a front end, and back end also I have a port number 80. These front end and back end port can be a different also, but for in my case I am using the port number 80 by default one. Health probe, I'll choose my health probe here. Session persistent, I'll keep it leave it default. Now everything I'll keep it default. It's not required for this particular demo. I'll just simply add it and we'll wait for the deployment is completed. So now LV load balancing rule deployment is also completed. So we have configured all the required things which we need to for load balancer. So now what I will do, I'll go to my this overview tab and I'll take the public IP address from here. Okay, where is public? Just give me a second. Okay, so this is my public IP address. If I just copy this public IP address, I'll put it here Now we will browse our application default.html. So this is going for this is going to virtual machine 1. If I'll just refresh it multiple times, it should go to VM2 also. So what I'll do, I'll open a new tab. Okay, we'll wait for 2 to 3 minutes to reflect the changes. So if I'll open a new browser here, Chrome, and what I will do, I'll just copy paste the IP. So if you can see the same IP addresses, in one browser we are getting a response of VM1, and in another browser we are getting a response of VM2. So basically that's how basically it's distributing the load in both the VMs. If I refresh it again, it's now VM1. If I refresh it again, it's also VM1. So if I'll again close this browser and open it, so now it's redirecting to VM1 in both the browsers. So basically like this, basically we configured the load balancing. This is just for a demo purpose. So I have created a one default HTML page and we are testing, but in real time you have web applications where you are redirecting or distributing the load particular set of virtual machine. So this is the configuration basically which you have to do in your environment. So that's all for today. Thank you so much. See you in next video.